Hi there, today we're going to do another video on the Rohde Schwarz CMU CRTU. Now, what we're going to do is we're going to do some TX tests on this, this military transceiver. Just flicker on. So what are my connections? I've got the antenna going to an attenuator, which then goes via a splitter into RF1 on my CRTU. On the audio side, I've made up an adapter that goes from the handset. I have a PTT button here. We have the receive audio going here. The transmit audio going there, so that's after it's demodulated from the radio, speaker output goes here, and the transmit audio from the microphone comes through here and goes into there. Now, the important thing to look at when you're doing this sort of testing is that you don't overdrive the microphone input. So it's important to look at your specifications and see what the level it expects on the microphone port of the radio. So we can see here, this is the J1 connector on this transceiver, and the specification the manufacturer gives us is 1.5 millivolts, right? So we won't be exceeding that, otherwise our testing is going to be all up the codswallop, and also you could damage the transceiver input section. Okay, so we just want to make sure that our transceiver's in the mode. I actually want to test FM deviation on this. So we can see we're in FM mode, we can see the frequencies 29.01. What we are going to do is we are going to go, this thing goes into secure loop, so we enter the password, it's done, we clear that. Now what we want to do is we want to go over to that CFIG. I just want to double check that the, let me press enter. It's radio I want to look at, so we're on TX low power, because this is running on battery, so it's a bit of a pain. So that's good. Oh, sorry, I'm trying to do everything here holding a cell phone. Scotch level low, that's good. CW offset, right. Antenna port B and C, so that's good. Silence, beeps, no internal coupler, bypass. FM deviation is what I was looking for. So we can see that this radio is now set up for 5 kilohertz deviation. You can change that to 8 or 6.5. So I wanted to make sure of that. So I'm expecting to see around 5 kilohertz deviation, and just some other settings there. So we'll just press clear to get out of here and put it back to the normal. Oh, come on, how do I get out of this program? Okay, so there we are. Alright, now we need to set up the CMU or your CRTU, whichever one you have. They're both pretty much the same. So you're going to need the amps testing option on your CMU, and you're going to go down to amps mobile station, and then we're going to go across to non-signaling tests, and we're going to go down to TX tests, and we want to, well, we'll just press, we want TX test, we want modulation actually. Okay, so there we are, we're in that TX test screen. Now we have to set the CMU or CRTU up. Now to do that, I've shown you how I've connected it up, right? We're going into RF1. So we need to hit the connect control, and we need to go to, need to hit connect, what have I done? Oh yeah, that's all right. Connect control, and we need to go and hit this button here. Right, this shows us what ports we're using. So we want to select the RF input as RF1. Now, because I have all these attenuators and splitters, I have worked out that the attenuation of the whole lot, I've done a cable loss calibration. I've got another video that shows that, so watch the other video because I'm not going to explain that in this one. I've already done it. We know that the attenuation here that I'm entering is 21.37. 21.37. Enter. Right, that's good. Now, there's something else that we need to change on, that we want to change on the screen. We will have a look at the analyzer, and we will have a look at the RF analyzer settings, I think it was. Bear with me, I've only done this a couple of times. Okay. We'll change the frequency away from discrete to continuous. Well, we could have it on discrete if we want, but the frequency I'm on is 29.01. And we'll enter that. Okay. And there's no offset. Now we will go back to connect control, and in this screen here we will look at the AF generator, and we are going to change the output level to what? We're going to change it to our document here said 1.5 millivolts. As you can see, it's set quite high here, so we'll set it to 1.5. Enter. Right, and then we will go turn the generator on. Where are we? On. You can see that that's on. Right. Now, one more thing we've got to do is we're going to have a look at the RF, the analyzer settings. Yep, the frequencies, it's carried that through for us. I just wanted to make sure that it's listening on the right frequency. So now, when I press my little handy dandy micro switch, which is the PTT for this transceiver, we can see that the carrier frequency error is 2 to 3 hertz. Peak deviation is 4.4 kilohertz, almost 5 kilohertz, which we had set it to. And we can see some other things here. We can see residue AM, we can see hum and noise, we can see the carrier power, and basically that will come up automatically when you transmit. So you can, it gives you quite a bit of information there. Now, these things here, the SAT frequency, the ST frequency, they're all to do with amps, which we're not interested in. Amps has like tones in the background and carriers and all this sort of thing. We don't have that on here. We have a carrier wave, which is our carrier frequency, and we have audio, and that's it. And we have deviation, of course. Now, some of this is coming up in red because of the settings. This is pretty much a go, no-go screen for AMP cell phones. So you can change what shows in red by going into this one here, pressing it again, and you can see you can control these items. You can, by the button, it's defaulted to that, as you can see. Press the limits. You can set limits for all these items. If it goes over the limit, it will come up in red over here. And you can change the audio filters, which is quite advanced stuff, and I must admit at this stage I haven't researched it all. My background is a ham radio operator. I'm self-taught, so I'm working this all out, and you know, it's an amazing bit of kit for educating, because you come across these things and go, hey, what does that do? Get on the internet, read about it, get into the Rohde Schwarz documentation, read about it, and figure out what's going on. Alright, well that's all I really wanted to show in this video. I'm not too unhappy about this. The radio's working, it's transmitting, the deviation seems to be within Cooey. I mean, I set it for 5 kilohertz, I'm getting 4.4. It's an older radio, you know, we're looking at about a 2000 or 1997 radio, so 20 years old. Components over time, they change their value, so I'm not too worried about that. But if it's a brand new radio, I'd be certainly going back to the manufacturer and saying, hey, you know, you say 5 kilohertz for, what was it, 1.5 millivolts. and I'm not getting that. So this is the sort of testing that we can do with the these Rohde Schwarz analyzers. Alright, thanks for watching my video. Cheers!